All right, so we're going to do that first. Okay, so and let me share my screen so you guys can see me. All right, so right here, when we say f of x okay, so or let me write this way. Over x squared all right, so what you're going to do first is we're going to do find first factor the numerator and denominator if possible. Why we say that? We say that factor the numerator or the denominator is possible. Why we say that? If we can factor them, it's going to make some calculations easier, right? Okay. After you factor, second, find the domain. After you find the domain, from the domain directly find the vertical asymptote. Directly after the domain. Okay, go ahead. I literally like a couple of minutes to do that. Everybody, please.
I said we can't see the problem.
You cannot see the problem?
No.
Ah, okay. I'm sorry. Okay, let me just share so I can have the go just a window, right? Okay. That way, if I go to explore my computer, you'll be able to see it. All right. Go ahead, everybody. Try to do the factoring, everybody, and a couple of minutes, please. All right. Go ahead, somebody. We know that the denominator is very easy to factor, right? Can you give me the factoring of the denominator? It is what?
X plus 3, x minus 2.
Thank you very much. For the numerator, can somebody give me a factoring for the numerator?
2x plus 3 and x minus 1.
2x plus 3x minus 1. Thank you. Of course, here the goal is not to go over the factoring methods. Okay, that is not the goal. Okay, we're just saying here when you factor, it does help to answer to some questions, right? For instance, after we factor, what is the domain? You see how the domain is going to be very easy to find after we factor. We said when we say the domain, we focus on what part of the function? We focus on
The bottom part.
the denominator. Thank you, the bottom part. So x cannot be what numbers for the domain?
2 and negative 3.
X cannot be -3 and x cannot be 2, right? That was the domain. And if you want to write this as an interval, it's going to be -∞, -3, union, -3, +2, union to infinity, right? All right. So, and we said last time there is a very tight link between the domain and the vertical asymptote. So, what are the vertical asymptotes then?
The vertical asymptote is x equals 3, x equals -3, and x equals 2.
Thank you very much. And x equals 2. Don't forget the x equals, right? You know, you haven't forgotten about it. If you say -3 and +2, you are giving me numbers, right? But you didn't forget about it. Thank you. Is x equal -3 and x equal 2. These are the vertical asymptotes. You see? All right. It means they are the red lines, right? You know, my graph right is if I want to go to my graph like this, if I want to go to my graph like this, I have -3 and +2, right? These are two red lines. It means when the graph gets close to these two lines, it is going to explode, right? It's going to go either to infinity or -infinity. We're going to say quickly how to guess that, right? But let's continue. Okay, find now find horizontal asymptote, if any. And you go back and you see what have we said about the horizontal asymptote. We're gonna compare the degrees of the numerator and the denominator, right? Okay. So which form is better for us to figure out the vertical asymptote quickly? This form or this form?
The top one.
The top one. For the vertical asymptote, for the horizontal asymptote, the top one is better, right? Because the top one shows us exactly the degrees, right? It shows us if the degrees are the same or if they are not the same. Okay, the degrees here are the same. I see degree 2, I see degree 2. Now you go back to your notes and you look what you said. When the degrees are the same, do we have a horizontal asymptote? Do we have a horizontal asymptote if the degrees are the same?
I don't remember.
You don't remember? Okay, so somebody is opening the notes. We said if the degrees are the same, there is a horizontal asymptote, right? And it is given by y equals the division of the leading coefficients, 2/1. Okay? So we said y equals 2/1, which is y equals 2, is the horizontal asymptote. I mean, the horizontal asymptote is very easy to find. It is even easier to find than the vertical asymptote, but you have to know that, okay? You have to know the three cases we said last time. If the degree, if the function is numerator heavy, if the degree of the numerator is more, then there is no horizontal asymptote. If the degree of the denominator is more, then y equals 0 is a HA. If they have the same degrees, then y equals the division of the two leading coefficients, okay? You have to know that. So y equal to is a horizontal asymptote. This is 1, 2. Right? That is horizontal asymptote. This is 2 here, this is -3, right? So now, y-intercept 5. Y-intercept. Remember, in general, not only to this case, but in general, when we say y-intercept, we have to do what? We have to do what?
Set x equal to 0.
Thank you. We have to set x equal to 0. Y-intercept is f of 0 always. The y-intercept for a function is always f of 0, if it does exist, right? How much is f of 0 here? When you plug in 0 everywhere, you said f of 0 is, 2 times 0 squared. I shouldn't do this. Is 163. I shouldn't do that. I just should give you the answer. F of 0 is -3 over -6, right? Why I do all these details and we are in 163? It's 1/2. So the y-intercept is the 0.0, 1/2. That is y-intercept. It's 1/2 right here. Right? Okay, so that is y-intercept. This is very annoying to do that. Okay, now for the x-intercept now. For the x-intercept now, which variable is set to 0? That's going to be number 6. Which variable is set to 0 for the x-intercept?
Sorry.
Y. And what represents y in my expression? What represents y? What side represents y?
F of x.
F of x, that is y, right? So we said 2x plus 3 times x minus 1 over x plus 3 times x minus 2 equals 0. Now, every time a fraction is set to 0, who is going to play something? Who is going to play? The numerator or the denominator?
The denominator.
When a fraction is set to 0, the only one that's going to play is the numerator, because the denominator will, you see, when you cross multiply, 0 times whatever is still 0, right? So you're going to set numerator equal to 0, right? Always. It is always set numerator equal to 0. That is the x-intercept. We set the numerator equal to 0. So we get what? We get x equal -3/2 and x equal 1. These are the two x-intercept, -3/2, 0, and 1, 0. So the x-intercept are 1, 0, and -3/2, 0, which is here. Okay. So now I was saying now, can we really in 163, can we really graph a function? I don't think we have the tools. You see, I don't think we have to. For instance, but just to give you an idea, if I want to know when I'm here, if my graph is this or this, it's very simple. When I get close to 2 from the right, if my graph is above or below, how I know that? I just plug in a number which is close to 2. I just plug in, for instance, 2.1, right? From the right. If I plug in 2.1, if I got a positive number, then my graph will be above. If I get a negative number, my graph will be below. So when you plug in 2.1, this is going to be positive. 2.1 is going to be positive. It's going to be positive, positive, positive. So it's going to be positive. So my graph will be like this. Okay? It's going to be above. So the below this will be there. And then I just go ahead. My graph will be something like that. Okay? If I want to hear on the left side of 2, am I like this or am I like this? Again, I plug in a number which is closer to from the left. I plug in like 1.9. When you plug in 1.9, this parenthesis will be positive. This parenthesis will be positive. This parenthesis will be positive. But this one will be negative. I have positive, 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 negative, right? If I plug in 1.9, everybody agree with that? 1.9, when you plug in 1.9, what's going to be 2x plus 3? Going to be positive, right? What's going to be x minus 1? 1.9 minus 1 is positive. 1.9 plus 3 is positive. But 1.9 minus 2 is negative. So my graph will be, the whole thing will be negative, so my graph will be below. So it's going to be like this. So that is not the part. So probably my graph will go this, right? Something like that. And now I go to negative 2. You see, this is the part I said we really don't know what happens. That is why in the test, I don't really insist for you guys to graph it. I will ask you about the asymptotes. I will ask you about the x-intercept, the y-intercept, all that. If you have a graphic calculator, you can use it to have an idea how is a graph, right? But we just don't have the tools. For instance, it's very hard for me in 163 to know how the graph will behave here. I don't know. You see, what is the maximum, etc., etc. I really don't. Now, if you choose, for instance, if you choose a graphing tool like Desmos, right? Everybody have heard about Desmos?
Yes.
You heard about Desmos, right? Graphing calculator. So if you have, okay, let me share my screen so you can see the Desmos stuff. Okay, what's happening? Can you hear me?
We can hear you.
Yes.
I just can't see your screen. We can only see
Yeah, I
like.
mean, I'm trying to stop sharing. Okay. All right. You know, Teams act up a lot. Okay. Now you can see me, right? I mean, you can see my screen now. So Desmos, if you say y equals 2x squared plus, what was it, plus x minus 3 divided by x squared plus x minus 6. You see, everybody, do you see the graph? This is how the
Yes.
graph look like? Okay, so the part we cannot figure out here, you know, in 163 is the part around 0. What is the maximum? You see, how far do we go up? I know the x-intercept, I know the y-intercept, we got all of them right, okay? But it's very hard to know in 163 how much we go up, right? Okay, and you can see here, even though the asymptotes were not graphed, they didn't graph the asymptote, you see? Even though we didn't graph the asymptote, you can see them. So if I go ahead and if I do x equal 2, you see, that's the asymptote. If I say y equal x equals -3, you can see the second asymptote in green. When I do y equal 2, you can do the horizontal asymptote. You see? Exactly. So, so that is why in the test, I will ask you, even if I ask you graph it, I'm not expecting to have a full graph, so to speak. If I say graph, for instance, if the whole problem is worth 10 points, probably it's going to just, you know, if you are able to graph the asymptotes correctly, you know, then I probably, you know, give you 9 points out of 10. If you have a graphic calculator, then you can figure out, you know, because it takes time and it takes some material to know how the graph behaves, you see, like this, how the graph behaves around here. I know how to figure out this part. I know how to figure out this part, no problem, you know, we just plug in. But the only part we don't know how to figure out is this part right here. That's the part we don't know how to figure out. That is the part we don't know how to figure out, right? This part in the middle, okay? But now, if you recapitulate, again, everybody knows how to find the domain. The domain is about what part of the function?
The denominator.
The denominator, right? The vertical asymptote, they are about what part of the function again?
The denominator.
The denominator. Vertical asymptote and the domain are very, very linked. The horizontal asymptote now, please, you see, when I asked you the question, nobody gave me the answer. Please go ahead and read the 3 cases. If it is numerator heavy, if it is denominator heavy, or if they have the same degree, right? Read that. The y-intercept is always f of 0. Y-intercept for any function is f of 0 if it does exist. The x-intercept it's about the numerator equal to 0. Okay, so these are easy calculation in the test. In any test, these 5 questions are easy calculation. Calculation-wise, they are easy. Okay, now for the graphing part, I repeat again, you know, I will not insist on that. I will not insist on the graphing part because we just don't have the tools. We have one last asymptote that we can talk about like very quickly. It was slant asymptote. I'm talking about it because you can see it in Alex, but I will not ask about it. You see, when that happens, a slant asymptote is an asymptote that is an oblique line. Asymptote that is an oblique line. You see, we have vertical asymptote, we have horizontal asymptote, now we have a slant asymptote, okay? When does it happen? It happens when the degree of the numerator, if the degree of the numerator is equal 1 more the degree of the denominator. Every time you have that, every time the degree of the numerator is 1 more the degree of the denominator, then we have a slanted asymptote. All right, for instance, f of x equal 3x squared plus 5x minus 7 over x minus 1. What is the degree of the numerator? It is 2. What is the degree of the denominator?
1.
It is 1, right? You see, the numerator has one more degree of the denominator. So we have a slanted asymptote, okay? So this is 2 here. This is 1 here. So we have a slant asymptote. How we get it? How the slant asymptote is of the form y equal mx plus b. That is the slant asymptote. How we get it? Very simple. To get the slant asymptote, divide 3x squared plus 5x minus 7 by the denominator x minus 1 to get the slant asymptote. Okay? And we're going to use a long division. And we're going to divide 3x squared plus 5x minus 7 by x minus 1. Right here. So, of course, here, all of us know how to do the long division. We can take these 2 divided by x, so it'll be 3x, right? We multiply, will be 3x squared minus x, minus 3x, I'm sorry. And then we subtract. We get 0 here, and then we get 8x minus 7, right? And then we divide 8x divided by x is 8. We get 8x minus 8, subtract, so we get 1. I even don't need the quotient. I stop right here. What is the slant asymptote? Y equal 3x plus 8 is a slant asymptote. It means, what that means? It means my graph is like this. If I graph y equal 3x plus 8, let me graph it. The y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. That is the y-intercept. When x is, negative 1, y is, 5. That is my line right here. Okay? It means when x goes to infinity or negative infinity, my graph will approach that line like this, something like that, right? When x goes to infinity or negative infinity, my graph will get close to that line, okay? Either in a positive way or either in a negative way, or either above or below, it could be like this, or it could be like this, right? So I can guess, I can check with Desmos. Let me graph it, 3x squared, just to show you slant asymptote. 3x squared, so let me clear that. Y equals 3x squared plus what? Plus 5x minus 7 plus 5x minus 7 all over x minus 1. Do you see that? You see the graph, how the graph is? So now let's graph the slant asymptote. Let us graph, just to show you the slant asymptote, let's graph y equals 3x plus 8. Do you see how the graph get close to the line at the end? They're almost the same, right? They are not the same. The graph gets close to that line when x goes to infinity or when x goes to negative infinity, right? You see, that is a slant asymptote. Again, we're not doing like if this was like a math major, we would do all this problem. We would do them like one by one. We would graph it, etc., etc. But we don't have the tools. We don't have like the tools to know how really to graph. We really don't. If I have a graphic calculator, it can tell you something, but we don't have those tools. Okay. All right. So that is, you know, this section about rational functions. Now, what is the new concept that we have seen? Asymptotes. These are the new concepts we have seen. But we knew what is the domain. We knew what is x-intercept. We knew what is y-intercept. The only new concept we have is a vertical asymptote, horizontal asymptote, slant asymptote. In my test, I will not ask you about the slant asymptote. I will ask you about vertical asymptote. I will ask you about horizontal asymptote, right? But not slant asymptote, because you know we're not using it otherwise. All right. So now what you're going to do now here is you're going to learn how to solve inequalities that are not linear. You know how to solve a linear inequality, right? Okay. If I ask you, all of you, do you know how to solve? Would you know how to solve x squared less than or equal to 4? Just tell me what do you think? What do you think we have to do to solve this? You would do that. Then what?
Like, do you put them both inside? I forgot what it's called, but divide them both by.
Take the square root, you mean?
That's what I meant. I'm sorry.
Take the square root.
Is that what you do or no?
That is not what you do. That is why, you know, inequalities are very, very, very different from equations. So when you have x squared equal 4, the square root plus or minus, right? We don't do that here. We don't take no square roots, right? That is, it is more than that. So this is what you're going to learn now. Why we have waited until now to do it? Because now we know how to graph polynomials, right? For instance, if I have my polynomial is like this, f of x is equal to x minus 1, right, times x plus 4. We know how to graph this one. We know we have 2 zeros. We did that in the test. We have 1 and we have -4, right? And then we both of them are cross point. You know, on the test, some people did graph very nicely, some people not, right? So we know we do the test point, and we know my graph will look like this, right? That's going to be my graph. So now look now. If I do this now, this part of the graph is above the x-axis, right? If my graph is above the x-axis, it tells me my function is positive or negative. What it tells me?
Positive?
It tells me my function is positive, right? Any graph that is above the x-axis, it tells you the function is positive, right? So now, if I ask you, where f is it positive, you're going to say, tell me f is positive on what interval? From what to what? From what to what? 1 to what?
1 to positive infinity?
Exactly, right? That is just one side. But I don't forget, this piece is also above the x-axis, right? It means my function is also positive here. So my function is also positive from what to what? From
Negative infinity to -4.
Exactly, right?
The union?
Exactly, and then we want to put the union between them. Okay, so now, if you were to solve this inequalities, like if somebody asks you solve x minus 1 times x plus 4 greater than or equal to 0, right? Do you see the solution on the graph? Do you see the solution to this inequality on the graph?
Is it
Somebody, what is the solution? I think we are looking at it.
negative infinity, -4,
Uh-huh.
1, positive infinity.
Exactly. Because when I look at my inequality, the left side of my inequality is exactly f, right? You see, the left side of my inequality is exactly f. So meaning every time you are able to graph a polynomial, you can solve some inequalities, right? If somebody else asks me, solve this. If somebody else asks me, solve this. Solve now. This is less than 0. I have to go look where the graph is where the graph is under the x-axis, right? Which is here. You see, the graph is under the x-axis here. Between what x and what x, the graph is under the x-axis?
Between 4 and 1.
Between 4 and 1. So if you ask me to solve the inequality x minus 1 parentheses x plus 4 less than 0, I would say the solution is -4, 1, the interval -4, 1, right? So basically, graphing polynomials helps a lot solving some type of inequalities, a lot. Okay, and this is what you're going to do now. So polynomial and rational, this is the last section, 3.6, polynomial and rational inequalities. 3.6, polynomial and rational inequalities. Okay, somebody asked me to solve x squared minus 2x minus 10 or minus 2x minus I don't know, minus 8 greater than or equal to 0, right? Don't take it lightly. Don't take this lightly, okay? Inequalities, at the minute the inequality is not linear, we don't take it lightly anymore. The only easy inequalities to solve, the only easy one to solve are the linear inequalities, okay? Everybody else have to be taken seriously. What I do? First,
x plus 4 and x minus 2.
Exactly, we call that factoring. Thank you very much, a factor, if it's possible.
I mean
It's x minus 4, x plus 2. What is a very, very, very common mistake from here? Or if somebody missed the class today, what they're going to do from here? They're going to do x minus 4 greater than 0 and x plus 2 greater than 0, right? You see? That is very wrong. You don't solve it this way, right? You don't split. We don't split it like this. What you're going to do? We're going to do exactly what we did if you wanted to graph. But here's the only thing here, we don't need the graph itself. We just need to figure out what are the signs. We're going to do this. We're going to put it here the zeros, right? What are the two zeros?
+4 and -2.
You see, the zeros are +4 and -2. And both of them are cross point, right? So it is -2 here and +4 here. And we're going to test, right? I want to know if my graph will be above or below, right? I want to know that. How I know? Remember the test point? You remember that? So what number I can test to the right of 4? What number can I test?
5.
5, right? So I test 5. So I have 5 minus 4, parentheses 5 plus 2. This is positive, so that's going to be positive. So my graph lies above the x-axis, positive. Remember, I just don't use the graphing, but if I were graphing, I would do this, right? But I don't need graph. I don't need the graph, so I can forget about it. I just need the sign. between -2 and 4. Because 4 is a cross point, what's going to happen? Where's the graph going to go? The graph going to go below, right? Everybody agree with that? Do we need to test another number between -2 and 4? Do we need to do another testing?
No.
Or we just know it's going to go below, right? That'll be a minus. -2 is a cross point. What's going to happen after -2? Where's the graph going to go?
Positive.
It's going to go positive. It's going to be plus. Every time everybody is a cross point, if all the zeros are cross point, you always have alternation. You have plus, minus, or minus, plus, minus, plus, right? So then, what is my solution now? You see, that is a chart. That is a signed chart. I don't have the solution yet. Read the solution. The solution is the sign that I'm looking for. I'm looking for where the expression is greater than 0. What sign I'm going to looking for? The plus sign or the minus sign? The
Plus sign.
The plus sign. And everywhere I see the plus sign will be my solution. I see the plus sign here. I see the plus sign here. So what is my solution then? -∞, -2. Okay, now, what do we have here? I have equal, so I have to close it. If I don't have equal, I have to open it, union for infinity. Do you see how little of calculation we have here? Do you see that?
Yeah.
Little calculation, almost not. Almost no calculation. The only calculation we did here is to factor, right? This was it. This is how we solve quadratic inequality. Let me give you another one here. Solve x squared minus x is greater, less than 12. Everybody go ahead. So what do we have to have on one side?
Zero?
You have to have 0 on one side. Thank you. And then you factor, you see, you have to have 0 on one side. And then you factor. And then you do this. And then you say solution. Go ahead.
Professor, I think I already solved it. Can I try my hand at it?
If you say what you want to, so you want to try it?
Yeah, I think.
Yeah. Let's give it like a couple of minutes for everybody else, and then you're gonna try it. I promise.
Okay, thank you.
Okay, let me first. Let me change the share. Just want to share the window, right? All right, as promised. Go ahead. Tell me what you got. The first one here to get less than 0. Tell me what you did.
Okay, I subtracted 12 from the right side, leaving 0 on that side, and then you get x squared minus x minus 12, and
Thank you.
that's yeah, and then you factor it into x plus 3 and x minus 4.
Thank you
And
very
then
much.
And then your zeros are minus 3 and plus 4, or positive 4, and then you, I believe you put the set as from negative infinity to -3, -3, 4, and then 4 to infinity, with the union symbol in between them all.
Yeah, but you know, before we read the solutions, there is some very important step that you need to figure out. In each interval, we have 3 intervals here, right?
Mm-hmm.
The right interval, the middle one, and the left one. In each interval, do you have plus or do you have a minus? Which means, is the graph above the x-axis or below the x-axis? To know that, we need to test point. We need to test numbers, right? To know that, you see. So we don't, before we read the solution, we have to have that, right? Okay. So now, for instance, to the right of 4, how we know if it is above or below? It is a plus or a minus. We just pick a number, any number, to the right of 4. For instance, 5, right? I put 5 here. 5 plus 3 and 5 minus 4. How much is that? This is positive, right?
Mm-hmm.
So it is positive here. Okay. And then between -3 and 4, we can predict it's going to be what? Positive or negative? We can predict it's going to be
positive, I think.
Look.
Negative.
Why? Do we even need to test again? We can use what? The 4 is a cross point, right?
Right.
Because the 4 is a cross point, across a cross point, the sign will always change. If it was plus here, it's going to be minus here. Okay? Across a cross point. Cross point, it is plus, minus, or minus, plus for cross point, always. Cross point, the sign will change across a cross point. And -3 is also a cross point. What's going to happen to the right of 3? -3. I'm left of -3. It's going to be positive, right? Now that we have that, now can we read the solution now? Yes. What sign are we looking for here? The plus sign or the minus sign? For our solution, what sign are we looking for?
Positive?
Where we refer to? Here. Less than 0, what sign is that? Less than 0 means a negative sign, right? So which sign, so which part of the number line we're going to highlight then?
The left side.
Which part of the number line we're going to highlight?
The left side.
Where do we see minus? Where?
In the middle?
Between.
The middle, exactly. Okay, I see minus in the middle, right? So, and do we include the zeros themselves? Do we include them? Do we close or do we open? What is the deciding factor of that?
It's not less than or equal, it's just less than.
Exactly.
So
Thank you very much. Thank you. So we don't include them. We say open. So the solution is the interval -3, 4. That's it. All right. We cannot read the solution until you put the signs plus, minus, etc. Okay. So if you have this, x minus 2 times 5 minus x, which is greater than or equal to 0, right? Here we already have the factorization. This one will go very quickly, right? What you do? What are the two zeros, please?
2 and -5.
Don't rush. 2 and? When you set 5 minus x equals 0, how much is x? 5 or -5?
5.
When you add x, it's going to be x equal 5, right? It's 2 and 5. And both of them are cross points, right? Now, I let you 1 minute, exactly 1 minute, to figure out the signs, plus, minus, plus, or whatever, right? Go ahead. Again, do not guess, don't guess. To answer to this question, plus, minus, plus, there is no place for guess. You just test numbers, that's it. You test numbers, you don't have to guess anything. All right, everybody, can you tell me what sign do you have? What sign do you have to the right of 5? The plus sign or the minus sign?
Negative.
Thank you. It's negative, right? You see, because if you test 6 right here, 6, you test 6, you test 6. What you get? You get 6 minus 2, parentheses, 5 minus 6. 6 minus 2 is positive, 5 minus is negative, so it's going to be negative. That is minus here. Okay, since everybody is a cross point, it's going to alternate, right? What's going to have here? Plus. What's going to have here? Minus. You see? Minus, plus, minus. Okay? Now, this is not done. This is not the solution yet. We have to write what is the solution. What is the sign I'm looking after? The positive sign or the negative sign?
Positive.
The positive sign. This says plus sign. Where do I see the positive sign?
In the middle.
In the middle, exactly. So the positive, this is a solution. So this is, the solution is right? 2, 5. Everybody see that? This is how we solve quadratic inequalities. This is the only way we solve quadratic inequalities, right? So now, how about rational solve? This is the same one right here. X minus 2 over 5 minus x. Greater than or equal to 0. So tell me, when you divide two numbers, right? Let's say you divide two numbers. You say 6 divided by -3. Or you multiply two numbers, 6 times -3. What is something that will not change in the two answers? Something that will be the same in the two operations. What?
The sign?
Thank you very much. The sign. Whether you divide or you multiply two expressions, the sign will be exactly the same, right? Everybody agree with that? So basically what we're saying, this expression right here, x minus 2 over 5 minus x, and this one, x minus 2 times 5 minus x, they will have exactly the same signs, right? Okay, they will be positive in the same intervals, they will be negative in the same intervals. We agree with that? Before we even do the math, they will be exactly positive in the same intervals, negative in the same intervals, right? What is going to be the only difference between the two solutions that we can anticipate? Tell me, what's going to be the only difference? What could be the only difference between the two solutions? Can somebody tell me? Before we do that, we're going to do that right now, but what's going to be the only difference between the two solutions, you think?
The answer?
The answer will be slightly different. Where is going to be slightly different? Where? Can somebody tell me? No? You see, I was also think somebody will tell me, in this one right here, there is a number that cannot be part of the solution. What is that number?
5.
5. The number 5 itself cannot be part of the solution. But here we included 5 in the solution, right? That will not happen here. But you know, that was just a side comment. But what you're going to do? Every time you have this, what you're going to do? You find the zeros of the numerator and the zeros of the denominator. Find the zeros of the numerator and denominator. What are the zeros of the numerator? What are the zeros of the denominator? What are they?
2 and 5.
2 and 5. You see, so we have the same chart. We have 2 and we have 5. From the beginning, I know 5 cannot be part of the solution. So what I'm going to do around 5 then? I'm going to put a circle, right? From the beginning, 5 cannot be part of the solution. So that's why I put a circle around 5. Now we do the same thing. You know, I want to know what sign is here. Is it a plus sign or is it a minus sign? You see? What I do, I test a number. What number are we going to test? We're going to test 6, right? What is 6 minus 2 divided by 5 minus 6? Is that positive or negative? Plus divided by minus, right? So it's going to be a minus. Okay? You see, it's going to be the same outcome as previously. It's going to be a minus here. So everybody is a cross point. The 5 is a cross point, the 2 is a cross point. What's going to be here? The sign between 2 and 5 is going to be a plus, right? Or I can test any number I want. I can test 4, for instance. 4 minus 3 is positive, 5 minus 4 is positive. What's going to be the sign outside the 2, to the left of 2? Is going to be a minus, right? Or I can test 0. 0 minus 2 is negative, 5 minus 0 is positive, right? So what sign I'm looking for? I'm looking for the positive sign. Where I see it? I see it here. We said 5 cannot be included, but 2 will be included because of the equal right here. Okay? So what is the solution? It is 2, 5, parentheses. So do you see the difference between this solution and this one? Is around the 5, right? Well, this is how we solve, you know, rational inequalities in this form. Now let me give you this one right here. Solve right? So you have to find the zeros of the numerator and the zeros of the denominator. In order to find the zeros of the numerator, what you have to do first for the, with the numerator? What you have to do first?
Factor the numerator.
Factor the numerator. Thank you very much. So if you don't have it factored yet, you have to do the factoring yourself. Okay, how can we factor the numerator? Can somebody tell me?
Take out 5x.
Thank you. GCF 5x parentheses x minus 2 over x plus 3 greater than or equal to 0. Now, after factoring, we're going to do this, and we're going to put all the zeros. Go ahead, put all the zeros. Put all the zeros. So what are all the zeros?
0, 2, and -3.
Thank you. We don't forget no one is 0, 2, and -3. Now go ahead. I let you have about one minute to figure out the sign, plus, minus, minus, plus. First of all, all of them are what? Cross points or turning points?
Cross point.
All of them are cross points, right? Because the multiplicity is 1, 1, 1, right? They all are the multiplicities, so they all cross points. All right, so somebody tell me what other signs you got? From right to left or from left to right? What you got?
From left to right, I got positive.
You got a positive here?
Mm-hmm.
And then?
Oh, I only did one so far.
Okay. So let's check the. So do you guys agree with the positive here to the left of -3? Everybody? Do you agree with the plus here?
It's a negative.
You got negative, right? Yes, I think so, because, okay, let's test -4, right? If you test -4, you get 5 times -4, parentheses, -4 minus 2,
I
Parentheses.
didn't mean over there. I meant from 0. I tested a point to the right of 2.
Okay, so the plus is here. Okay.
Yeah.
Okay, so then I agree with you.
Okay.
The plus is here, right? When you test 3, for instance, if you test 3, we have 5 times 3, parentheses 3 minus 2, parentheses 3 plus 3. Everybody will be positive, 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 positive. That is a plus. Because everybody is a cross point, we don't need to test again. It's going to be a minus. It's going to be a plus. This is going to be a minus, right? What is the sign we're looking for? The plus sign or the minus sign? Because of this, what sign are we looking for? The plus sign. Where do we see the plus sign? Between?
Negative 3 and 0 and 2 and positive infinity.
Exactly. What number cannot be part of the solution anyway? What zero cannot be part of the solution? What number? It is negative?
3.
Negative 3. We should include the other ones because we have equal, but negative 3 cannot be included. So the solution is negative 3, 0, union 2, infinity. All right?
Sir, please, I have a question.
Yeah, go ahead.
Okay, if we had less than 0, less or equal to 0, so the solution, can we use the interval negative infinity to negative 3 because we have an asymptote?
Yeah, it's going to be, yeah, I mean, even if we have an asymptote right there, but less than or equal to 0 will involve, the solution will include negative infinity, negative 3. We have just opened at negative 3. If I understand what you're saying, if my inequality was less than or equal to 0, right? If this was the inequality to solve, then I would go with this and this, right?
Yeah, but we have a limit at negative 3. So I think
yeah, the only way to express negative 3 is an asymptote. X equal negative 3 is an asymptote that is not part of the solution. The only way to express it is to put parentheses around negative 3. That's it. That's enough, right? It's just to put parentheses. It's just to open at negative 3. Exactly what we did here. You see, we did not include negative 3. It doesn't matter if it is less than or equal to or greater than or equal to. It doesn't matter. Negative 3, the only way to say negative 3 is not part of the solution is to put a parenthesis around negative 3. That is it. If you do something more, that can make it wrong. It is right. All right. Okay, so this is almost the end of the class. So this is the end of class. So if you look at the calendar, you will see the quiz will be next week, right? The 16th. I will open the quiz on the 16th, right? I will open the quiz on the 16th, Tuesday 16th, and then you will have 1.5 days to submit your quiz. Just like quiz number 1, just like quiz number 2. 4 or 5 questions on chapter 3. Okay. From the vertex. Yes, go ahead.
And then we're going to do it on the paper and then take a picture and send it.
Yeah, exactly. So the quiz, I mean, even if we are supposed to, even if we are supposed to do the quiz like with no notes, all that, but a quiz is, of course, the context of the quiz is easier than the context of the test, because now it's like a take-home quiz. You have time, etc., etc. So take opportunity for that. to maximize, with integrity, always integrity. When we do the test or quizzes, we always assume somebody is watching us, even if it is take-home quiz. Integrity, but maximize your grade on that is going to help. Okay, so that's going to be the last quiz we will be done before the last test. Okay, so it's going to be on chapter 3 from the vertex. Quadratic functions, how to find the vertex, x-intercept, y-intercept of quadratic, and how to find the zeros of a polynomial. I promise it's going to be maximum is going to be a degree 4. Maximum is going to be a degree 4. How to do the synthetic division. You see, how to find f of how to evaluate a function using the synthetic division. And finally, the vertical asymptote, horizontal asymptote, domain, x-intercept, y-intercept of rational functions. And then what we did today. Each topic, each section will have like one question. And that's going to be a good review for the test, the upcoming test. All right, don't miss the quiz. When I open it up on Tuesday, please don't miss the quiz. When we miss assignment, it is a 0, right? So you have to avoid missing assignments. Thank you very much, everybody.
Thank you, Professor. Have a good day.
Thank you. All right.